Alright, so I'm going to give you an example of how to solve one of these specific heat capacities, and it's just a transfer of energy within a system. So this is specific heat capacity, SHC. And here we're going to have iron. We're going to put it into a known temperature with a known specific gravity, specific heat capacity of water, and then we even know our specific heat capacity of iron. And we're going to plug all that in, and we'll be ready to go. So let's get ready. We start with our knowns and put them in. We're going to start with the specific heat capacity of water. And this really depends on what your unit is, but you're going to want to use the one in the book. This one here is 4.184. That's kilojoules per kilogram Kelvin. And let's just keep that in mind. Sometimes it might be 418. Just look at this unit. In the books, I don't think it's going to try to fool you. It's going to give you some of these measurements beforehand, and also you want to look in your book on the page that has all the specific heat capacities and go with that number. So we have that, and then we know the mass of the iron, 21.5. And then we know 100 degrees is initial. In Celsius here doesn't matter as much. Insulating container of water, the mass of the water is 132. Heard my email there. And its temperature before it, and the iron is 20. And it even gives a specific heat capacity of iron at 0.449. So then the only thing we don't have is temperature final of the water and temperature final of the iron. You might say it's two different things we don't know, but really it's the same, because we're going to put the iron in the water and their temperature is going to reach equilibrium. So if you remember, we had this Q of W equals the negative Q, the loss of energy, of X. X here is going to be the iron, and then if we plug in what these are, it's the specific heat capacity of water times the mass of the water times the change in temperature of the water, which can be final minus initial. And that's going to equal, I'm going to get this negative out here. So we'll go 0.449. And then we have, actually, what am I doing? Let's not go that quick. So let me go specific heat capacity of iron times the mass of the iron. I got a little bit too ahead of myself. And the change in temperature of iron. Okay, and then we plug our numbers in. So we know 4.184. These take some calculations, lots of numbers. The mass of the water is 132. And then temperature final, we do not know. And then temperature initial is going to be 20 degrees for the water. So we kind of got to put this in parentheses, because we don't know one of them. Then we do the other side, specific heat capacity, don't forget the negative, 0.449. We get that 0, point in there. The mass of the iron, 21.5. Temperature final, we don't know. The going to be the same as the water, and then we heated it to 100 degrees. Okay, and then we just do the math. So if I get my calculator out here, and I take 4.184 times that by 132, that gives me 552.288. And then we're going to want to multiply that through using the distributive property. So I'm just going to do that. So it's going to be 552.288, and then temperature final, T of F. And then we're going to multiply that by negative 20. So go back to that. We'll just go 20 and make it negative. So that's going to be a negative 11,000. These numbers get pretty big. 11,045. Not going to worry about the decimals on this one. Maybe just 1.8. And that's going to equal, I feel like I have enough room here. And so we'll do the 0.449 times 21.5. And then we're going to do the negative through the first one. So 0.449 times 21.5. That equals 9.65. We're going to go with that one. It's going to be a negative. We're going to run the negative through that one. So that equals negative 9.65. And that's going to be T of F, right? And then we multiply that by 100, right? So it's going to give us 965. It's going to be a negative, so this makes this a positive. Positive 965. Okay, now we'll just double check it. Make sure I didn't make any errors. Yep. So 965. And now we're ready just to collect like terms. So we have this T of F, 552.288. So we're going to add this one to it, right? Because we want to add this to get rid of it. So 552.288 plus 9.65 equals 561. That done. 0.94. So we're going to go with. That's T of F. Then we're going to move this stuff over. This is a negative. We're just going to add it to the other side. So we got, let's clear this somehow. There we go. Okay. So 965 plus 11,045.8. And then we get equals 12,010.8, right? And then we just divide by the 561. Okay. And we will get .4. So there's not much change, as you can see. So in the end, they'll both be 21.4 degrees Celsius. That's how you do them. And you should see temperature's not going to go down because the object's hotter, so it should go up. And that is your example. Use that to complete the other problems in the book, and you should be ready to roll. And let me know if you have any questions.